This lecture involves the intensity of light. That essentially the further one gets from a source, the lower the intensity. And we can apply this to both sound and light. The further I am from a sound source, the less intense it's going to be. In other words, the less volume and the lower the decibel value. In terms of light, it's going to be less bright. We can look at this using the inverse square law, that light appears less bright or less luminous the further the observer is from the light source. So on the left here, if I imagine that I have a light emitting source, I can call it a light bulb or a star. The rays coming out of the emitting source represent photons. What photons are the pure energy that we call light, traveling in straight lines, and that's why we see these arrows. As you move further from the source, the intensity of the light appears to decrease. This is called the inverse square law. As I increase the distance from the source, I decrease the luminosity by its inverse square, or the object appears less bright the further I get from it. So here's how it works. According to the inverse square law. According to the law, the power of the light will be inversely proportional to the square of the distance. Now it sounds really wordy, but think of it this way. If we take a distance of 2 and we square it, we get 4, that the inverse of which would be 1/4, or rather a quarter of the original power, not half. Therefore, light intensity is 1 over d squared. So let's look at that, because those sound a little bit messy. Let's say that I have a value at 1 meter. If I go to 2 meters, notice if I'm 1 meter away, it has a value of, let's just say 1. If I go twice as far, if I'm 2 meters from the light, it's going to have 1/4 the intensity it did when I'm at the 1 meter mark, right? If I'm 1 meter and I have an intensity of 1, if I go 2 meters, I'm twice as far. I'm going to have 1/4 the intensity. If I go 3 meters from the light source, I'm going to have 1/9 the light intensity. So the inverse square is simply saying that if I am 4 meters away from the source, if I originally started off with, let's just say 1 watt, and I'm 4 meters here, I'm only going to have 1/16. It's going to be much, much dimmer at this location. It doesn't say that the brightness changed. It simply says the way I perceive that light is what is decreasing. And it's decreasing at an inverse square. So let's do some numbers here. For the inverse square law of intensity, let's say that at 1 meter away, I have an intensity of 8 watts per meter squared. That if I am 2 meters away, right, if I think of it this way, 2 by 2 area, it's only going to have 1/4 the intensity as it was at 1 meter away. It's going to be 1/4. So 1/4 of 8 watts per meter squared is 2 watts per meter squared. So let's do the math. A light has an intensity of 10 watts from 1 meter. Okay, so I'm changing this number. 10 watts from 1 meter. What happens to the light's intensity if one is further from the source? Well, I just lectured to you that the intensity decreases by an inverse square. So what is the light's intensity at 2 meters away? Well, 2 meters is 2 times further than 1 meter, so it's going to be 1/4 of 10 watts. Therefore, 1/4 of 10, or 10 divided by 4, is 2.5 watts of intensity. So what if the light's intensity, or what is the light's intensity if one were 4 meters away? Well, 4 meters away from my reference of 1 is going to be 1/16. So 1/16 of 10 meters is going to be 0.6 watts per meter squared. And I would take my 10 watts at 1 meter and divide it by, if I'm 4 meters away, it'd be 1/16, right? Inverse square. The distance of 4 meters further, 4 times further, is going to be 1/16 of 10. So that's 0.6. So let's do it a little differently. Let's say we get closer to the source. Getting closer to the source leads to an increase in light intensity. So here's my given. At 5 meters, a light source has an intensity of 10 watts. What happens to the light's intensity if one is closer to the source? Well, it increases by an inverse squared. So if I have 5 meters away and it's 10 watts, what is the light's intensity if I am 2.5 meters away? In other words, if I'm half the distance, if I square that, I'm going to have 4 times the intensity. So 4 times 10 watts is 40 watts at 2.5 meters away. So let's do this a different way. Let's say, what is the light's intensity if I am 1 meter away? Well, notice my reference says at 5 meters, it's 10 watts. If I'm 5 times closer, it's going to be 25 times more the intensity at 5 meters. So 25 times 10 is 250 watts. Make sure that you know what the concept of light intensity is and how to solve using the inverse square law.